Hello guys, welcome back to VC Tech. In today's video, we are going to be diving into one of the most important protection in your switching environment, spanning tree protocol, also known as STP. Now, STP is what keeps the network stable by preventing switching loops, because one wrong loop can literally bring down an entire network. But the truth is, STP can also be a target for attack, as an attacker can plug in a rogue switch and send malicious BPDUs and take over your entire network topology. That is, if you are not protected. So in this video, I'm going to break down why STP is important and how attackers try to exploit it, and most importantly, the steps that you must take to prevent STP attack on your switches. So sit tight and stay focused, and let's secure your switching network the right way. Now, why is STP important? STP prevents switching loops in a network, as it ensures a stable layer 2 topology. It also automatically disables redundant paths, as it helps maintain network uptime and reliability. STP security and threats. Well, these are the threats that you get to encounter if you don't configure STP on your switch. Rogue switches can attempt to become the root bridge by bringing their priority number down. I'm going to show you what that means when we get to the lab. BPDU spoofing can also disrupt the network path, as misconfiguration of ports can cause temporal loops. Now, these are the ways that we prevent STP attacks: by enabling BPDU guard on edge ports and use root guard to protect against rogue root bridges, and also apply BPDU filter where it is needed. By doing that, we have control access to the switch ports. So for this tutorial, we are going to be using 3 switches and 3 PCs. I'm going to show you what every PC and every switch will be playing a part in this tutorial, as we also have a notepad for the steps to take. This is going to be our guideline for today's tutorial. First, we have our switch and our PCs, and let's do this. We'll be doing this for every switch. So, and remember to take notes, because this is going to be a bit of a long video, because there are lots of things to actually get from this video. As you can see on the screen, we have our root ports. We have our root ports, designated ports, and blocking or alternate ports. I'm going to show you where this port fits in this topology and how it helps the network remain stable and also prevent STP attacks on a switch. So for this switch, let's go and do show version of the switch. Take note of this. This is the MAC address of this switch. And also let's do show spanning tree. As you can see, it is showing us no spanning tree instance exists. Let's also check the version for the other switches. Remember, this is the MAC address of this switch. We are going to come to that. And also let's check for this one. We have to go enable do show version of this, and this one has the last 2 numbers to be 68. The previous one was 58. Let's check lastly for this one. Do show version, and this one has 91. All right, so let's also check do show spanning tree here. Let's see what we get. Also, no spanning tree instance exists. Now, it does not exist because we've not plugged in any cable to any of the switches. So we've connected the switches and the PCs together. And guys, take note of the time that it is taking for it to actually connect properly, for the signs to be showing green. It is taking usually it takes 30 to 50 seconds for the sign to turn to green from orange. Now let's check our STP. So as you can see, previously when we checked, there was no spanning tree. However, now we have this information right here. I'm gonna bring this to the center of the screen. So we have this information now showing us that we have a spanning tree enabled protocol with IEEE. As we have the root ID to be 32769, we also have the address, which is the MAC address of the switch. Now for this, we are seeing the bridge. This bridge is the root. So how did they get the root bridge? Because previously there was no root bridge. As a matter of fact, there was no spanning tree that even existed. But now they have a root bridge. So how did they get that? Automatically, when you connect multiple switches together, they exchange BPDUs and they select which is going to become the root bridge of the network. They do that by the priority ID and the MAC address. Now, the lower the priority ID, the winner of the network topology that will be serving as the root bridge. All right, so every switch comes with a priority ID, and also they come with a MAC address. As previously we checked to see the MAC address of each router that we are using for this network topology. Let's also check on this device and see what is going to be the spanning tree of this switch. So there are informations that we have here that was not on the root bridge. So this one has a root ID, which now the root ID, they've now selected this guy. That is why previously we were seeing this bridge is the root. So how did they make this guy the root? As I said, the priority and the address. So this, remember, this switch has 32769 as the priority ID. Let's check the priority ID here, 32769, the same. Let's also check the priority ID on the last switch. So do show spanning tree. And this one has 32769. So they all have the same priority ID. Let's now analyze from the MAC address, because they pick who is going to be, the switches automatically pick who is going to be the root bridge by checking the lowest priority ID. Now for this, they all have the same priority ID. Now let's go and check the MAC address with the lowest number, because that is going to serve as the root bridge of the network. For this switch, we have the MAC address to be DD91 as the last MAC address to be, or let's just say the last two MAC address to be 91 for this switch. And for this one, we have the last two MAC address to be 68, which is lower than 91. Then for this switch, we have the last two MAC address to be 58, which is lower than the previous, which was 68. So they were able to pick this switch over here to serve as the root bridge because it has the lowest MAC address, as this one has 68 and this one has 91. So the lower the MAC address, or the lower the priority ID, the more likely for that switch to serve as the root bridge. Now let's check our notepad because we are going to be working with the guideline. Now we have seen how the switches select the root bridge in the network. Now let's also manually configure. Let's make another switch the root bridge in this topology. And now for this, we want to make this switch to serve as the root bridge of this network topology. We can do that by, you can say, spanning tree. Then for this, we see VLAN and we assign it a number. We want to be giving it a number of 1. We also want to set the priority. Now this is where you set the priority. If you want to make the switch, if you want the switch to have a lower priority ID, this is where you have that configuration. And the configuration, the lowest ID you can have or that you can set is 4096, I believe. Let's check that. 4096. Yes, 4096. However, if you try to do something, let's say 500, it is going to tell you that the number 500 is not in the table, as they have either from 0, 4096, 8192, and so as we have, this is the number, that the priority number that every switch on our device is using. Now we want to make this switch up here the priority, so it is going to serve as the root bridge of the network. We can do that by saying, making the priority 4096. So this is the configuration for when you want to change the priority ID on a switch. This is what you're going to do to change the priority ID. So now let's check our spanning tree table once again. Previously, this device, this switch right here was the root bridge. As it shows here, it was serving as the root bridge. Now it has changed. It's no more serving as the root bridge anymore. Why is that? Because somebody now has a lower priority ID. Now who has the lower priority ID? Let's check this guy and see what he has. So this device is now serving as the root bridge of the network topology, as it says that this bridge is the root, and it also has the number that we set. Even though the MAC address has 68 as a high number, where we have 58, it went first with the priority ID before they go to the MAC address. So that is how we can manually configure a root bridge on a switch. Now what do we have next on our guideline? So we have to enable BPDU guard on every access port on the switch. So what is an access port? An access port are those ports that are connected maybe to a PC, to a printer. Those are access ports. So on this switch, we have just one PC that is connected to the switch. So this is an access port. Now let's enable BPDU guard on the access ports on every switch on the network topology. So from FA0/3 to 24, and also gigaports 1 to 2. We are going to enable BPD UGAD on those ports. Let's do that we can do that by saying interface range, interface range FA0/3 to 24. So let's just keep it this way, and we want to enable BPD UGAD on the access port. How do we do that? First, we have to let the switch know that from FA0/3 to FA0/24, they are going to be serving as a switch port. So we say switch port, the mode should be access. Now they are all switch ports. We also want to say spanning tree, and we want to enable BPD UGAD. So we are going to enable BPD UGAD on the switch port from 3 to 24 as we have here. By doing that, we've enabled BPD use on the ports on the root bridge. Let's also do that on the other switches, as we want to be interface range FA0/3 to 24. We want to say this port should be serving as a switch, as an access port. We also want to enable BPDU on the switch. So I'm just going to copy this. So we enable, and we say we want the port to serve as an access port, and we want to enable BPDU on all the ports on the switch. Now we've enabled BPDU. What do we have next on our guideline? We have to enable port fast. Previously, I'm going to bring out one PC so we see how port fast work. So I'll put one here, and I'm going to bring out this one. I'm going to put this one here. Now let's enable port fast. Previously, when I connected all this cable, it took a while. It is going to take 30 to 50 seconds for it to actually come up. As you can see, it is showing, both sides are showing that it is up, as it's showing green. Now let's bring out one more cable and try this. We'll connect this to this. You can take notes on how long it is going to take the switch and the PC to actually connect. That is because we've not configured port fast on the network. So just keep watching. It is going to take that long time. Now let's us configure port fast on the network. So we say spanning tree. Previously we did BPD UGAD. Now we'll be going with port fast. So we say port fast. What we just did now is we've activated port fast on all the ports from 3 to 24, that whenever we plug in a device, it will not take that much time as it took the PC to connect to the switch. Now let's connect this device and see what happens. How long did it take? Literally, it just connected immediately because we've activated port fast. I'm also going to disconnect this cable and let's try something now. Not a switch. I need to disconnect a cable. I'll disconnect this one also. I'll disconnect this one, and I'll also disconnect this one. So remember, we've configured port fast on this switch over here. that whenever we plug in a device, the device comes up very fast without wasting that time. It does waste from 30 to 50 seconds. I'm going to plug this device. I'm going to plug this device. Also plug this one here, and watch the time is taking. We'll just wait a bit. Now let's also plug this one. So let's see how long it takes. It did not take any time. It just connected instantly because we've configured port fast on the interfaces of the switch. So whenever we connect a device, it comes in very fast. So that is a port fast enabled on that switch. Let's also try to enable port fast on this other switch and see how long it's going to take for the devices to come on. Let's do that here also. Spanning 3 port fast. We've configured port fast on every interface on all the switches. Let's try that one more time. So let's also connect these devices and see if our configuration were accurate. Let's start with this guy, and as you can see, it came up immediately. So it means we have our port fast enabled on the switches. So the reason why this is not accurate is because we only were supposed to configure what's it called? We did not configure BPDU on interface FA0/2. So let's do that and try that one more time. FA0/2. We want to say switch port mode to be access. So take note, this is just the same thing that we did previously. We're just doing it now for just one interface. So we want to say spanning 3. Spanning 3, let's enable BPDU. And also spanning 3 for port fast. And let's try that one more time. As you can see, our configuration now is accurate as we've enabled port fast on all the switches on the network topology. Let's also check what we have. So now we'll be talking about how to enable root guard on uplink access port. So next we'll be talking about how to enable root guard on uplink access port. So what is a root guard? Root guard protects the root bridge from rogue switches that would want to pretend to become the root bridge in the network. So where do we configure root guard on a switch? This is where it gets a bit tricky, as you should pay very much attention to this part. Previously, when we checked let's check that one more time. When we check the spanning 3, so you do show spanning 3. These things right here are very important. Take note, guys. All the ports on the root bridge is showing designated. This right here is the rows is designated for all the ports. Let's also check this device, this switch device. Do show spanning 3. Now on this device, it's different as we have two designated ports and one root port. Now, what is a root port? A root port is the port pointing towards the root bridge. So this right here is a root ID, because this is where it is pointing towards the root bridge. So this link right here is the root port, as it is pointing directly to the root bridge. Now for this, I'm going to bring this down so we have enough space for this tutorial, because we need to know how these configurations are done. Sorry if I'm keeping it messy. I just want everyone to understand what is about to go on right here. So take note, guys, this link right here is a root port, as it is sending data direct to the root bridge, or it is directly connected to the root bridge. These are root ports. So on this switch and this switch, those are where you configure the root guard, telling every port on the switch that whoever tries to become a bridge root, that they are there to protect that port. They already have a bridge root for the network topology. Now let's configure that in the network and try to connect another switch, because it works with a switch. On the access ports, a PC could connect. However, if a switch tries to connect and you set the priority to become the lowest ID, it is going to shut it down, as we are going to see in the step to come. So we want to configure root guard on the access ports on this switch. So what port is this one? So from 2 to 24, FA0/2 to 24, we want to say spanning 3. We want to say guard and root. By doing this, we've configured guard roots on the interfaces from 2 to 24, letting them know that they already have a root bridge. If there's any other switch that tries to pretend to become the root bridge, is going to be shut down by the bridge root. Now we're also going to do the same configuration here. So interface range FA0/2 to 24. We want to say spanning 3 guide root. Now we've configured guard root on the both switches, telling it that any device that tries to connect, any switch device that tries to become the root bridge, should be shut down. Let's also try that. Let's bring out a switch and let's connect the switch. So as you can see, the port immediately went down, as it cannot serve as the bridge route. We've already configured BPD UGuard on that switch, telling the switch that any other device that is not a phone, or that is not a laptop, a computer, a printer, that tries to connect, they should shut it down. And switch is one of those devices that we've told to, because this whole STP attack prevention is to prevent rogue switches to connect and try to become the bridge routes on the network. So we've configured the root guard on this switch. We've also configured BPD UGuard on that switch. So any switch that tries to connect will immediately get shut down. So next on our list is to use storm control on access ports. Now, where is the best place to enable storm control? What ports is the best ports to enable storm control? Yes, if you're saying on an access port, yes, you're accurately right, as we are going to enable storm control on the port that is connecting to either a PC, a printer, a phone, an access point, any end device. That is where we enable storm control. So with that being said, let's head over and enable storm control on the ports that are connected to end devices. We say interface range, and for this it's FA0/2 to 24. And we want to say storm control broadcast and the level should be 10. So interface range FA0/2 to 24. You want to say storm control on all the ports. I want to leave, let's say this one, I want to leave this for 15. Interface range FA0/3 to 24 /3 to 24. The storm control broadcast message for this should be on level 20. So this is it for this device. Once the traffic is more than 10, it sends the remaining traffic out of the network. It drops it. This one is 15 and this one is 20. So this is how we set storm control on a network when we don't want attackers sending ARP floods to flood the network and cause the switch to crash or the network to crash. We set a storm control. Remember, this is a root port and this is a designated port, a port pointing to other switches, as we only have just 3 switches. If we have more than 3 switches, those other ports pointing to another switch are considered designated ports. Now lastly on our list is to disable unused ports. So all other unused ports on the network, we are going to shut them down. So an attacker cannot come and plug a rogue switch on our network to disrupt the flow of traffic in the network. So how many unused ports do we have? As we have this one to be 2 and this to be 3. So from 4 to 24 are unused ports on this switch. First of all, let's create a VLAN. Let's create VLAN 10 for this, and let's name this IT. No, let's name this something else, unused. So we want to say interface range FA0/4 to 24. We want to say shutdown, and we also want to move those switch ports to VLAN 10 that we just created. If we do show VLAN, we are going to see that the remaining ports that are not being used, they've been moved to the unused VLAN that we just created. Now you can see how we protect the ports on the switch, as we've enabled BPDU to prevent STP attack on switches, and also how to prevent rogue switch to connect to our switch and try to act as the root bridge. Now let's also do the same configuration on this switch. So interface, first we need to create VLAN. So we want to give this VLAN VLAN 1, and we want to name it same unused. Default VLAN 1 may not have this. Oh, okay. So VLAN 11, and we want to name this unused. We also want to move all the unused ports interface range to the unused and shut it down. So range FA 0. How many ports do we have here? Four ports. So from 5/5 to 24. We want to the switch port access VLAN 11. We want to shut those ports down. If we also get a new PC and try to connect it once again from that device, you're going to see that it is going to be impossible for it to connect. We've configured and also shut down every port on the switch. So guys, this is how you actually take full control on all the ports on the switch, as you can configure BPDU guards, you can configure port fast so the links could come up very fast. And remember, you don't configure port fast on the ports connecting a switch to a switch. It is advisable to configure port fast on the ports connecting a PC to a switch. End user devices are where you're supposed to configure port fast. If this video helped you understand how STP work and also how they select the bridge route and how to change the priority ID if you want another switch to serve as a bridge route, if it helped you understand how it works, please like, subscribe, and also share this video for more tutorial.